Hello, everybody, and welcome to my talk. Thank you for coming to my talk. Today, I will be talking about an argument against functional programming. So, first of all, a few words about myself. I have been a functional programmer in Scala for more than 6 years by now. And in past, I was a very big proponent of purely functional style. Currently, I'm working as a compiler engineer at LAMP at EPFL. So I'm working on Dhoti, on the next version of Scala. In past, I have been really dedicated to purely functional style. And I was really evangelistic about functional programming. And even to create the most trivial web application, I used to draw category theory diagrams and stuff like that. I was heavily using libraries like cats for all this stuff. However, in my professional journey, at some point I started to encounter problems and challenges that were what I call them style invariant. So I noticed that it doesn't really matter for me what I use, either imperative style or functional style to solve these problems, because these problems are style invariant. And furthermore, I noticed that it can be extremely dangerous to be blinded by the face in the purely functional styles that it is a silver bullet that can resolve these problems. So this is the attitude that I used to have in past. I used to treat the functional style as a sort of a silver bullet for more or less all the problems that I had, but I found out that it is not the case. So with this talk, I would like to share my experiences with purely functional style and the problems that it, in my opinion, cannot solve, the problems that are style invariant. I would like to draw attention to these problems that I perceive to be very important software engineering problems that are, however, style invariant, so they cannot be tackled by purely functional programming. I would like to share some lessons that I learned during my software engineering journey so far, the lessons related to how exactly to solve these problems best. And I would like to convey some examples of the challenges that made me less passionate about functional programming. And most importantly, this talk I would like to serve as a reminder against looking for a silver bullet in software engineering, because this is a mistake that I used to make myself in past. So without further ado, let's just jump straight into it. And I would like to share my, first of all, my vision about how I currently view software engineering problems and why exactly it might be dangerous to be blind to certain blind spots that that you cannot see if you do not use software engineering this way. So software engineering is software solutions, from my perspective, are more closely described as stories. So these are stories that you tell to yourself, to other people, and to the machines you're trying to program. These stories, first of all, reflect the vision of the problem and the vision of the worldview that you are using to view the problems in. So this is your worldview. And the solution that you're describing in your software is the reflection of this worldview, and it is defined in terms of your worldview, of the worldview that you're using to describe solutions. And the key point about the stories is that they are supposed to be clear. They are supposed to clearly communicate certain information to other people, to yourself, and to the machines that you're trying to program. So let us see what exactly can go wrong if you get your stories wrong. So I would like to show a little example, which is a Levenshtein distance calculation in Dhoti. In this example, we will see two ways to solve the given problem, one functional way and one imperative way. So in the functional case, we made a mistake by being more or less blind to other things but functional programming. So we tried to solve the problem in a purely functional way because we thought it was a good way. the way to go, and we were blind to other things that mattered about the story we were trying to tell. So first of all, what is Levenshtein distance and why would it matter to our compiler, to Dhoti? So Levenshtein distance is a metric that describes how different two strings are. Informally, it describes the minimum number of modifications, single character modifications, that you need to make to turn one string into another. These modifications are insertions, deletions, or substitutions. This is a dynamic programming algorithm, and here is how it works by an example. So suppose you would like to turn the word Saturday in the word Sunday. So what you have is your algorithm works against certain metrics that we will talk about a bit later. But what is important for this example is that the Levenshtein distance between Saturday and Sunday is 3, because it takes 3 operations in total to turn Saturday into Sunday. Precisely, the way you do that is from Saturday, you need to delete one character A, then you need to delete the character T, and then you need to turn R into N, and you will turn the string Saturday into Sunday. So the question is how exactly to compute this number of total operations, this Levenshtein distance. As I said earlier, it is a dynamic programming algorithm, and it works against the matrix, the two-dimensional array that you can see on the slide. As the way it is constructed, the dimensionality of this array is depends on the length of the two strings that you're comparing. The dimensionality is the number of columns is greater than the length of your string, of the first string, by 1, and the number of rows that you have is greater than the length of the second string, also by 1. So the way it works is as follows. First of all, the first column and the first row is populated by incremental numbers. So if you look at the first row, it is 0, 1, 2, 3, 4, 5, 6, 7, 8. So why exactly it is the case, what these numbers mean? So they mean the number of modifications, single character modifications, that you need to make to the corresponding substring of Saturday to turn it into an empty string. So why empty string? Because the first row corresponds to the empty string. So to the left of it, you can see an empty character. So it is an empty string. So if you look at the number 0 in the first row, it corresponds to the modification of an empty string to an empty string. And the meaning is that you need exactly 0 operations to turn an empty string to an empty string, which makes sense. Next, the number 1 corresponds to the transformation of a string S into an empty string. So how exactly do you transform an empty string to, how exactly do you transform a string S to an empty string? You just drop one character S, right? So this is just a single one modification, and hence the Levenshtein distance between S and an empty string is 1, and so on and so forth for all the substrings of Saturday, starting from the beginning. The similar meaning is for the first column. It is the meaning of it is the amount of transformations, the amount of modifications you need to make to an empty string to turn it to the string, to a certain substring of Sunday. After you have this after you have this first row and first column populated, you proceed to populate the remainder of the matrix according to the formal definition of the Levenshtein distance algorithm. So in this formal definition, as you can see, we have 2 cases. First case corresponds to the scenario when either of the indices is 0, which we have just covered. So it is the case of the first row and the first column. And the second case is when we are in the middle of this matrix. So we are working against non-empty first string and non-empty second string. And the way we compute the value of the matrix at a certain indices I and j is by taking the minimal of 3 values. So what are these values? So first value that we consider is directly to the left of the values that we are trying to populate. So it is a Levenshtein distance with the index 1, I minus 1, and j. The second value is the Levenshtein distance of I and j minus 1. So this is the value directly to the up from the current values that we are populating. Also, you will notice that to both of these values we add 1, because the meaning of these two values is the deletion or addition correspondingly. So if you perform an addition or deletion from a string, we must add 1 to the total count of operations that we perform. The last values that we consider, the last minimal values that we consider is I minus 1 and j minus 1, and it is a value that is directly diagonal to the values that we are trying to populate. So in order to, so if you populate the matrix this way, we will come to the Levenshtein distance for both of our strings, both of our target strings in the bottom right column of bottom right cell of the matrix. And the way we infer the meaning of the operations that need to be performed from this matrix is we do that by starting from the bottom right cell and then following to either to up or left or diagonally upwards to the least possible number present in this cells that I named. So for instance, we start from 3 at the bottom right, and then we follow diagonally to 3, because 3 is the least number from the least neighbor to of this 3 that we are starting from. And since we have not modified the value that we have started from, we are not performing any operation. However, if you look at the value corresponding to R in Saturday and N in Sunday, it is the value 3. So the next, the minimal neighbor of this value is 2. And this means that between these two steps, between 3 and 2, 1 operation was performed. And since the meaning of the diagonal transition in this Levenshtein distance matrix is the transformation. So what is the meaning of the transition from 3 to 2? Is the meaning is the modification of R, of the character R into the character N. Similarly, the meaning for the transition from right to left, as you can see in case of T and S, T in Saturday and S in Sunday, the meaning of the transition to the left means deletion. So if we go from 2 to 1 in, as you can see in the red arrow, we must delete the character T, and similarly we must delete the character A. Right, so this is the way the algorithm works. Now, why does it all matter? Why do we care? We care because in Dhoti we use the Levenshtein distance to make suggestions when users make typos. So it makes sense because in order to make good suggestions, we need to calculate the minimal distance from what the user inputted to one of the correct values that the user must have intended. On the screenshot here, you can see 2 implementations that we had at some point in Dhoti of Levenshtein distance. The topmost implementation was at some point replaced by the bottom implementation. So this is a diff of one of the commits that was made to Dhoti. We replaced the top implementation by the bottom implementation. If you look at the top implementation, we tried to make it in a purely functional style. So we tried to avoid all mutation. We tried to use the collection primitives such as fold left, scan left, zip, etc. to describe what the Levenshtein distance algorithm entitled. However, at some point we felt the need to to replace the implementation by the imperative one. And the reason was because the functional implementation had bugs, and it was so difficult to comprehend that we ourselves just thought that it would be easier to replace it with the imperative implementations and try to understand the codes that we had. And this happens pretty frequently because the person who have written this code, this functional code, they already left the lab, and the code was written a long time ago. So there was no person that had a working knowledge of this code. And so the learning curve to understand this code was pretty steep. And so we decided that it would be easier to resort to an imperative implementation. So why exactly it is so difficult to understand the functional implementation here? What exactly is so wrong with it? So in this talk, I would like to attempt to dissect what exactly was wrong with this implementation. And first thing that jumps to our attention is that functional programming solution deviates from the formal definition of the algorithm very significantly. So if you look at the imperative solution to the problem, immediately it is pretty easy to track what is going on, right? So first we have the definition of an array, which has the dimensionality corresponding to the dimensionality of the strings we're working with, which is according to the definition of the algorithm. Then we have an iteration of this array using the for loop, which is per dynamic programming algorithm, per definition of the Levenshtein distance. And then at each iteration, the meaning of each iteration is to define the value at indices I and j of the matrix. And if you look at the Levenshtein distance at the formal definition of the Levenshtein distance algorithm, it is exactly how Levenshtein distance is defined formally using a mathematical formula, right? So in every point I and j, we have the value of this algorithm besides the value of the matrix to a certain value. Also, if you look at the imperative implementation of this algorithm, the body of the for loop, the body of the variable of the dist j and I, it follows the formal definition of the Levenshtein distance pretty closely. So first two lines of the if branch, so if j equals 0, then I, else if j equals 0, then j, and they follow the first line of the formal definition of Levenshtein. So if the minimal value of I and j equals 0, so if either I and j equals 0, then we take the maximal of I and j. So this is pretty much what happens in the first two lines. The second two lines of the if branch, they also follow the implementation pretty closely, and they mimic the three values considered in the minimization of the Levenshtein distance. So if the characters of the strings are equal, then this corresponds to the diagonal transition through the matrix without really changing the value. So on the picture, you can see that a lot of times we transit from the value 3 to the value 3 to the value 3, all these black arrows. So this transition is performed when the characters of two strings are equal. The last case corresponds to the case when the two characters of the strings are not equal, and they consider three minimal values as per the Levenshtein distance algorithm, as shown on the formula. Right. If you look at the purely functional implementation of this solution, we can see that we cannot as easily perform a one-to-one mapping between our implementation, the functional implementation, and the formal definition of the algorithm. So why exactly that matters? Why do we care about following the formal definition of the algorithm closely? Well, first of all, it simplifies the onboarding of new people on the code base. So imagine you come to our code base as a new person. You do not know our code, but you have a working knowledge of the Levenshtein distance algorithm. If you have the working knowledge of this algorithm, you will be able to understand the imperative solution pretty easily. So the onboarding cost will be reduced for you. However, if you are talking about this functional solution, this cannot be said about the functional solution. So even if you know how Levenshtein distance works, you come to our code base and you still need to do a lot of work to understand what was going on in the mind of the person who implemented our functional code, because it doesn't follow the formal definition of the algorithm. So the cost of onboarding is increased. And even if you're not talking about onboarding, the cost of maintenance also goes up, because at certain point, in certain time, you forget your own implementation. You have other things to deal with, other projects, and the way you implemented the solution is forgotten by you. So in future, it will be harder to maintain it. The other aspect that I would like to address in this example is the amount of concepts necessary to understand the solution, both functional and imperative. So I'm talking about the concepts that are needed to work with collections. In case of a purely functional solution, we have 3 concepts that are necessary to work with collections. These are fold left, these are zip, and these are scan left. If you looked at its functional implementation, all of these concepts are used there to make it happen. In case of imperative solution, we have only one such concept. It is the for loop. And this concept is pretty widely known. Like every programming language has the for loop, and every programmer knows what it does, which cannot be said about fold left, scan left, or zip. So this is some extra obscurity and extra learning curve, extra onboarding curve for the project. The other thing to be addressed is the amount of variables to keep in mind. I would argue that the amount of variables to keep in mind is pretty important for code understanding. And also it is pretty important to understand where these variables come from. The reason why it is important is because variables is the data that our algorithm is supposed to work against. You want to understand the algorithm, you need to understand how exactly it transforms the data. So if you look at our imperative implementation, it is quite simple. So you have only 5 variables. You have 2 variables that come from the function definition, S1 and S2. You have 1 variable that is defined in the body of the function, which is the array, the dist array, also pretty trivial, just an array definition. And then 2 variables come from the for loop, which are also pretty easy to grasp. If you count the variables in the functional implementation, we get 8 variables. So we have n1 and n2 that come from the definition of the function, the arguments to the function distance. Then 2 other variables are priv and x, which come from fold left. And here we might encounter troubles understanding them, because to understand what these variables are, you need to understand fold left. So the control over the definition of these variables is inverted. No longer the user is in charge of defining these variables, but the fold left is in charge. It gets even trickier if you follow the algorithm even further, because fold left has a nested zip and a nested scan left, which have their own variables. So zip doesn't have variables, but still zip is pretty tricky to understand, because there are 2 zips involved. So 1 zip is fine, but 2 zips is already getting tricky. However, scan left is getting pretty insane, I would say. Because if you look at the body of scan left, we have the pattern match, we have the case, and this case has 4 variables. The names are not descriptive at all. They are just single letters. You cannot infer the meaning of the variables from looking at the names of the variables. Further, to understand what they are, you need to understand what scanLeft does, because this is scanLeft that defines these variables, not the user. And even further, to understand what scanLeft does, you already need to understand what foldLeft does, because scanLeft is nested on fold. And scanLeft uses the variables that come from foldLeft. So you need to perform a lot of leaps of abstractions to follow the values of the variables in your code, which is not good for the understanding. Finally, the final thing that I would like to address is that the mutations, the difficulties and the complexities of the mutations in this code. So if you look at the imperative implementation, we mutate the array and we perform the point-wise mutations of this array. So if you look at the body of the for loop, we have dist of j and I equals to blah, 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 to some value. It is a mutation of one integer at a time. It's pretty trivial to grasp. In case of functional implementation, at first glance, you might consider that it doesn't have any mutation at all, which a functional program is which is the way the functional program is supposed to behave. However, I would argue that the mutation is still present here, and the value that is mutated is the variables that come from foldLeft and scanLeft. So look at the variable prev, for example, the variable that comes from foldLeft. So clearly, the code inside the body of foldLeft will be executed multiple times, because foldLeft is supposed to be iterative process. It is supposed to be a loop. And on each iteration of this loop, the value prev, the variable prev, will be different. So I would argue that this is mutation enough, at least for the purposes of understanding the code, what is going on. And the same argument can be made for scanLeft. So all these variables that come from pattern matching on scanLeft, all this h, d, v, y, variables with obscure names, they all change from iteration to iteration. And you as a programmer need to keep that in mind. So all in all, the takeaway from all this discussion is that the story that we are trying to tell becomes very obscure and difficult to understand. It is very easy to lose control if you do not have a robust and simple story in mind. It is very easy to lose control over your code base, and then in half a year, for example, you do not know at all what is going on. What is going on in that code base? Like nobody at all knows what is going on in that code base if you give it like 1 year or half a year or so, because everybody is on the other stuff. And to regain control is extremely difficult because the story is very obscure. Again, to emphasize, this is not the problem with functional programming here. This is a problem with the blindness to certain issues that are style invariant. I think that if you try hard enough, you could implement the functional solution also in a very neat and tidy story that will be quite easy to read and to understand. However, it will be tricky to do since the algorithm is defined as a dynamic algorithm, but I think it is possible. The problem is not the functional style. The problem is that we were too blind trying to implement things in the functional style. We were too blind to other problems, the problems such as simplicity to maintain code and simplicity to understand code. So my point that I'm trying to make here is that functional style is fine as long as you keep your story straight, as long as you understand what you're trying to say. The other example, one example of, in my opinion, correct storytelling, correct composition of your software project, how I do that in my practical situations, as the example of the Dhoti ecosystem mentioned. So in Dhoti, we have a community-built test. So a community-built test in Dhoti is a set of Scala2 projects that we take from the wild, and we try to recompile them with Dhoti, just to see whether Dhoti can do everything that Scala2 can do. However, it is pretty challenging to maintain that build. Why? because we need to keep our copies of these projects up to date with upstream. We need to synchronize between the independent changes done within the Dhoti team. So if one person modifies the project and then another person modifies the community project independently, we need to make the changes play well one with another. And also we need to maintain certain conventions in the projects to avoid mess. And here is where my little in-house project comes in, which is a Dhoti ecosystem project. This little project defines the central point from which we can manage our community build. It defines the rules which we must follow to interact with our community build. Since we have the rules that we have, we can automate the procedures we can automate following these rules. Also, from this project, we can define what it means for a community build to be okay, for a community project to be okay. So what it means for it not to have any problems. And this is needed for us to be able to automatically detect problems when they arise. This project exists as a REPL. So on the screenshot, you can see how this project looks like. So it is a REPL, you type in a command, and then you get a neat table. So if you look at the table, it lists all of the projects that are present in the community build in the first column. And then in all the other columns, it lists the criteria that all the community projects must satisfy. And if the criteria is satisfied, then the color of the correspondent entry is green. If it is not satisfied, it is red. So for example, in our community build, we have a convention that all of our community builds must reside on the Dhoti community build branch of our copy of our fork of the upstream REPL. So if this criteria is not met, if the branch is named otherwise, we get a red entry, and it means that we need to do something about the situation. So how exactly do we implement this software project? So the main point to see here is how to make this little REPL project happen and how to implement it in a maintainable way as a very simple and concise story. How to tell the story of this REPL. In order to tell the story, to write the story of this REPL, we in my workflow, I focus on what exactly are important points about this story. So the two most important facts about the project are, first of all, it is a rule book, so it is a set of rules that a project follows, and then it is a REPL. So it has a certain form in which a user can see this project. And hence we have in our code base, we have two top-level files. First, the check project file, which defines the rules that the project that any community project must obey. And second, we have the execute commands file that defines the list of commands and how to run them. So why exactly this matters, this organization of code base? It matters because it tells a simple story for the newcomers to the project and for the future maintainers. So if you are a new person that comes to the project and tries to look at the code base, most probably you are not interested in the technical details of the implementation. Most probably you're interested in things like what happens when I run the check command, as on the screenshot here, we run the check command. So how exactly that happens? Or what are exactly the rules which the community build must follow? So you have these two things in a convenient locations in the top level directory of the project. So this was to say about the organization of the code base itself. Now we can look at the file called execute-command.scala and see how it is organized. So again, It is organized in a way that is easy to read, that focuses on readability and that focuses on the on the nice way to tell a story, clean way to tell a story. So immediately, functional programmers of you might notice that the case exit throws an exception. So we do not care about this because it doesn't impact readability. However, it doesn't bring any problems either to our code base, this side effect, because inherently REPL is side effectful. You want it to perform side effects. So if we type in exit, we want exit right now. So it is fine for us. It plays well for our code base. Otherwise, this execute command file contains only one top level function, which is called execute command, not surprisingly. So to increase readability. And since the nature of this file of this function is to differentiate against commands, is to define what happens when you run different commands, we basically just reflect just that in the body of the function. So we strive to preserve it simple, and we strive to keep it down to a single big match statement, nothing else. It is really important for us that if the function is if its spirit is to differentiate among commands, then its shape must also follow its spirit. So we keep it clean this way. Right, so this was about the execute command function. Another issue that I wanted to very briefly address is other set of style invariant issues like feedback loops, like process and their standardization. So what is this all about? So in my work, I encountered that increasingly stuff like feedback loops and processes that are, you can even say that they are programming language independent. They increasingly matter for the quality of work. So regardless of your style, there are certain things you do repetitively at work. Most of the time, there is room for these things to be more efficient. And if you do not take your time to do your housekeeping, to do your homework, then you risk to end up in a mess and drop the quality of your project. So this is also very style invariant. It doesn't have anything to do with functional programming or imperative programming, but this is something that I found very important in my work, and I would like to just address it and discuss it a little bit. So first example is our debugging in Dhoti. How do we debug Dhoti? So usually what happens is that we have a small, very minimal program that doesn't compile as expected. Then we try to reproduce this error locally. We modify the compiler a little bit. We modify the flags with which we run the compiler, and we run it. We obtain some feedback, and then we repeat the procedure in a loop until we fix the issue. Now we have certain challenges and certain rooms for improvement while following this debug loop. And the point is that we can follow this debug loop for like dozens times per issue. And so if there are even tiny things for improvement, tiny imperfections in the workflow, they accumulate in flow of these dozens of times, and this becomes a huge time waste. So one of these huge time wastes is the commands that we use to run Dhoti to compile the programs. They're pretty huge. So if you look at the screenshot here, we have an example of an SBT command that we run to compile, in this case, 2 files. So one file is macro1, the second file is macro2. And the point is that from SBT, we need to frequently modify this command because, as you can see, this command has certain flags like xprint inline, ycheck, yprint pause. It doesn't matter what these flags mean, but the point is that they provide feedback. They provide feedback to the compiler engineer about what exactly happens in the compiler. So we need a systematic approach to simplify the modification of these commands. So long story short, since we do not have a lot of time, long story short, we have implemented a little a little compiler plugin that allows us to write these SBT commands into scripts. So no longer command line modification, but modification from scripts. And what it gives us is the ability to very easily jump to the flag that we want to modify and comment it out. And this will give us an edge, an increased productivity when we need to repetitively modify the command dozens of times. Again, this is to emphasize that this is a very important problem, which might not seem as important at all, but if you do it like dozens of times, it is pretty important, which is totally style invariant. However, it is very impactful on the quality of your work. So the other thing, very briefly to show, so this is the thing that I'm sure very familiar to any person that is Scala programmer. This is an exception trace. So what we did in Dhoti, what I'm doing in Dhoti for myself is I modify this trace a little bit just to highlight the method names and to make lines and the locations of the trace of the exceptions clickable. And this proved to be a very big game changer for me as a compiler engineer, because it allows me to jump to the lines where exceptions happened very easily by one click. So if you need to do that dozens of times, this ability to not waste time jumping lines matters a lot. Right, so key takeaways. So what I would like you to carry out from this presentation, the message that I would like you to deliver. Again, I would like to emphasize that personally, I do not have anything against functional programming, even though the talk is called the argument against functional programming. However, with this talk, I wanted to draw your attention to an entire class of software engineering and software engineering related problems that are style invariant. So it doesn't matter if you think about your code base as mathematical equation, or if you think about it as an imperative thing, you will still encounter these problems. So for instance, the problem of telling a concise story, the problem of having to maintain that code base in like a year, 5 years from now, when the staff of your team has totally changed and you will need to reread this code. So it is important to tell the concise story. And sometimes it is very acceptable and it is very useful to trade the purely functional style with its style benefits for the imperative style if the problems that you're trying to solve is inherently imperative. There is nothing wrong with that. Personally, in my work, I tend to use this rule of thumb that if you cannot explain it to a 5-year-old, you do not understand it well enough. So if you cannot explain something otherwise than with functors, cofunctors, monads, comonads, etc., then chances are you do not understand it well enough if you cannot boil it down to the very essence that you're trying to do. Unless, of course, you're doing something very theoretical and something very inherently academic that doesn't have any practical implementation. But if you're working against a very practical code base, trying to solve a real world problem, you should be able to explain it equally to another person, to yourself, and to a computer in a very clear and concise way. So the other thing is that there exists a class of software engineering problems that are style invariant. And the entire reason I'm making the entire talk about these problems is that in my experience, the impact of this style invariant very little problems on my quality of work is far, far greater than what I can achieve looking at the style. So thank you very much, everyone, for your attention. And I guess we will have the question and answer session next Saturday as per our agenda. So thank you for your attention.
What are the biggest challenges that are in front of your team?
Well, currently we have entered the phase where we more or less stopped actively developing the new features, and we are trying to stabilize everything, stabilize the language. So currently, from my perspective, the main challenge is migration of the ecosystem. because lots of issues arise during migration. So stuff like binary compatibility, backwards compatibility, source backwards compatibility. Next, we are trying to maintain the community build, which is composed of all the Scala 2 libraries that we ported to Scala 3. So these depend one on another. So it is pretty difficult to get it right, how to manage all this ecosystem of projects and their interdependencies. The other big challenge, I guess the biggest challenge with migration is macros, of course, because Scala 2 macros stopped functioning in Scala 3. So in Scala 3, we have totally different macro ecosystem. And what it means is that whenever we need to migrate a project from Scala 2 to Scala 3, we need to essentially rewrite all the macros from scratch. So, and another thing is how to make the Scala 2 macros and Scala 3 macros cross-compile between Scala 2 and Scala 3 in the same project. So you have the same project and you want it cross-compile between Scala 2 and Scala 3, and how to get this, how to get the macros right, how to separate them so that you do not need to have two separate jars. So this is also a direction in which we are thinking how to make the ergonomics good migration-wise.
I have a question. It's about concretely how will be the transition from Scala 2 to 3. Will there? I don't think it will be possible to merge. So because they are in two different GitHub repos.
Mm-hmm.
So are you going to somehow port Dhoti to the Scala 2 repo, or stop the Scala 2 repo at one point in time? Yes, how concretely are you going to do the transition? Regarding also there is a question about the library. Currently, Dhoti uses the Scala 2.13 library. Is it planned to have a Dhoti rewritten library with a new Dhoti feature? Or will you wait for Scala 3.1, for example, to have a Dhoti only library?
Mm-hmm. So regarding your first question, it is a merger of Scala 2 and Scala 3. So currently the situation is that the Scala 2 repo and Scala 2 is totally maintained by Lightband. So we at EPFL, we do not really maintain Scala 2. At EPFL, we only maintain Scala 3 and its repo. And I do not think it is very likely that we will consider merging the two repos together, because well, they're very different and there is a lot of work to be done to do this merger, a lot of planning to be done, and I do not think it will add a lot of value to the project. Currently, we have stabilized, more or less stabilized Scala 3. We are working on stabilizing it. It works for us as it is. So we do not see it as priority right now. About the standard library, as far as I'm aware, like I'm not working precisely on that area, on the library and its migration, but as far as I'm aware, there is no effort to port the library right now to make it to make the Dhoti dedicated library. However, we are planning to do that in future, so maybe after the cert release. But again, I am not working directly on this effort, so I cannot tell like with high degree of certainty how it is going to be. But as far as I am aware, there are on the ScalaLang website. At one point, we have published the related materials of how the migration will take place, the roadmaps. So I believe in the blog there is more detailed description.
Okay, thanks.
Mm-hmm.
Hi Anatolii, this is Nitya. I have a question regarding Sparc. You know, because Sparc currently is developed using Scala 2.
Mm-hmm.
is there any plan to redevelop using Scala 3 in future? Because even if we are using Scala 2, the most stable version that we have is Scala 2.11. So how the transition, even like in future, if we will have Scala 3 for Sparc, so how the transition will go from Scala 2 to 3? Because we have to move from Scala 2.11 to 2.14 and then to Scala 3, or directly we can move from Scala 2.11 to Scala 3.
So thank you for your question. And currently we are developing the migration plans and the migration strategies for to facilitate the migration. However, it is important to understand that any such migration will require a lot of effort. And Sparc is a pretty huge project, so it will require a lot of effort regardless of the strategies that we have. So concretely, what we are working on is various compiler options. So for example, when you try to compile a project using Dhoti, you can set a compiler option that would point your intent that you're trying to facilitate migration from Scala 2. And this will make the .c compiler, the Dhoti compiler, behave in a little bit different ways. So which ways concretely? For example, it will display you warnings instead of errors in certain places, and it will point you which places of code needs to be rewritten to be compatible with Scala 3, to be compatible with Scala 3. Yeah. Currently, we are still in the process of working out such a strategy. So the situation is that right now we have only we have been feature complete for a bunch of months, and previously all the effort went to the development of the new features, and currently this effort is only shifting towards basically the documentation and migration. These are two directions that we are focusing on right now. So as far as I'm aware, there is one significant chunk of such migration strategy would be a bunch of compiler options for .c that would allow the user to smoothen the transition to Scala 3, and some of the options will even allow for automatic rewriting of the old syntax to the new syntax. However, again, personally, from my perspective, Sparc is a pretty big project, so it will require effort to migrate. Somebody will need to handle this, regardless of any strategies that we will come up with.
Okay, and have you started working on a Sparc, or is there any timeline for that?
So far, we are focusing on, we have our goals a little bit lower. So currently what we are doing migration-wise, EPFL team is doing the migration of LiHoE's libraries. So LiHoE has done a lot of effort in the development of sane Scala libraries that are supposed to be easy to use and that are supposed to handle very essential operations that you encounter in everyday programming. So for example, LiHoE has libraries for HTTP requests, for interacting with the file system. There is Ammonite for scripting. There are libraries for JSON processing and so on. So it is less ambitious than Sparc. So if you take Sparc, it is machine learning, it is heavy data processing. So far we are starting with baby steps, with something that everyday user can get started with and use in everyday life. Even these small efforts even these small libraries prove to be quite work consuming. So probably it will take time to implement this. However, we hope that it will give us experience of porting such libraries, and we will be able to compose some kind of guidelines for the community to help port their community libraries as well.
Okay, thank you.
Mm-hmm.
I can tell you my story if you want.
Cool.
So your talk was about basically functional programming techniques are not always the answer to everything, right? Yeah. So I don't know when it was, maybe 10 years ago. It was when John McCarthy was still alive. it occurred to me that John McCarthy's style of programming in Lisp, functional programming, and Donald Knuth's style of programming are completely different. Donald Knuth is very much an imperative programmer, but his programs are great. I mean, except for maybe the tech language, that people have some issues with the design of the language, but it works really great. It doesn't have bugs. He writes really good code, but it's not functional code. But they both taught at Stanford, and it always occurred to me, it always made me wonder, do they get along? Do they, because their styles are so different, but they're both really nice people. I mean, I've met them both. They're both really nice people. And I think it was in 2008 or 2009, I asked John McCarthy, how do you and Don Knuth get along? And he said, oh, we get along great. And he told me a story from 1973 when Knuth had just finished, I think, volume 3 of The Art of Computer Programming. And he got the Kyoto Prize. And there was a reception at Stanford for faculty to, basically congratulate Knuth. And so John McCarthy goes up to Knuth and he says, congratulations on your prize. You must have read, 500 papers to write that book. And Knuth said, no, it's 5,000. Okay. So the story is that behind every page of a Donald Knuth book is 10 research papers that he read to write one page in his book. So, but anyway, but John McCarthy said they got along really well. This functional guy and this imperative guy, they got along really well. So that's hope for you in working in the functional world and the imperative world. These two worlds can exist very happily together.
Yeah, exactly. Thank you for your story, and I think it is exactly right. We shouldn't allow things like paradigms to be a lot of barrier between programmers.
Yes, one question. I suppose, like me, you are locked. So, can you continue working for EPFL remotely, or are you doing some other things?
For us, it is fine. We are working remotely. I mean, everything happens online, so it is fine.
Okay. And yes, one other question. It was regarding Stéphane Tancoua talk about different kinds of polymorphism. I don't know if you have attended his talk, but he gave some information regarding higher ranked type and polymorphic values. He said that they might be supported in Scala 3. Do you have some information about that? Because I tried to replicate his example, and it has the same output as Scala 2. So are polymorphic values going to be supported in Scala 3?
I'm not sure I can tell you something concrete on this, because I'm not really working on that precise area, the type level stuff. So it is more of our PhD students that are handling.
Okay.
I can say that I see your effort in Dhoti because on February it was impossible to write something without writing a bug report. But now I have 2 weeks without bug report to Dhoti. So it's a progress.
Yeah.
Yes. About what I want to ask, it is very important for people to think different and think outside of usual standard trajectory. of mind. And we have functional standard. When you say A, then you say B, C, D. We have imperative standard, yes. So the question is no, it is easy to say that something is not ideal, yes, but what is other? So can you say or point us to paradigm, yes, which will give us a better vision than our standard trajectory?
You mean what is my vision of what is more important than styles like imperative and functional, stuff like that?
No, yes. What is more important for you? What you can point? Yes, and what is and what is maybe some third, maybe logical.
Well, for me, I have noticed that after a certain time in the software industry, the focus for me started to shift from the paradigms themselves to things like the way I organize my project, the tools I use, and basically writing the same code. And these are things that might sound very trivial because using the right things, using the right tools is like very basic thing. However, I noticed that if you really pay attention to how you organize your work, your tooling, and more importantly, not allowing yourself to get blinded by wanting to write purely functional code or purely imperative code or writing in certain framework. More than that, just focus on writing same code that you as a person tries to understand well. I noticed that if you focus on that, your productivity just increases greatly. So far for me, rather than functional and imperative code, I view software development as storytelling. So whenever I'm writing a new software project, I'm trying to tell a story more than anything else. And if this story is better told functionally, then it is functional. If the story is better told imperative, then it is imperative. But I try not to focus on the style because it is, after all, just a style.
That sounds very interesting because, you know, Knuth had literate programming, and you're talking about programming in terms of storytelling.
Yeah.
I think you ought to develop that. You ought to write an article someday on your thinking on. No, I'm serious, because you know, they say that one of the biggest impediments when you're hiring people is software engineers have great mathematical brains, but sometimes have a hard time explaining their meaning, you know, to other people. And storytelling sounds like a great added value, you know, to what we do.
Yeah, and not even to other people. I think if you can
To yourself.
Yeah, exactly.
Yeah, just so that, you know, next week you can remember what you were doing last week.
Exactly. And even the same week, you understand it clearly and you don't have any bugs that come from lack of understanding.
So do you have children?
No, I don't.
Okay. I was thinking, when you do, if they can understand your code, you've won.
Yeah, most probably.
Because they always say, if grandma can understand, you explain it so that your grandmother could understand it, but maybe also so your children, because they'll have to maintain it.
I like the phrase that if you can explain it to a 5-year-old, you understand it.
Well, the 5-year-old will find bugs that you won't find.
Yeah, they think in a different way, outside of our box. Our engineering is a big problem.
But functional programming is not the stuff you can easily explain. It's always way more complex than imperative approach. So it depends.
Yeah, depends on the person you're explaining to, I guess.
Yeah.
Their background.
In my experience, every developer, early or later, comes to functional programming. And once he or she tried it, he or she don't want to go back. But you can't just jump into functional programming straight ahead. you have to evolve, to appreciate, to understand the value. So I believe that functional programming and touch technology, they are not for children, they are for adults. With all respect.
Well, functional or imperative, I think the code should be sane and well understandable.
You are now in Scala world, or you listen and think about new languages?
No, I'm currently totally focused on Scala. It's always been my favorite language, so so far I haven't found anything better.
Yes, and interesting also, are anybody in EPFL work on the differentiable programming?
Differentiable. Oh, I believe, yeah, I believe there are two of my colleagues. No, actually, one of my colleagues who was interested in automatic differentiation. So they were trying. So he was trying to. He's a postdoc, but he's currently leaving the lab. So I don't know whether he will try to continue the project. But he was trying to. He was writing the papers about that, and also. Besides him, he was closely working. He was closely working with our macro guy, Nicolas Suki. So he might also have the background, and maybe he will continue in this area because it seems to be very, very nice application to macros.
Thanks for your time, and
thank you everyone for
really,
thank you for making the conference.
Thank you very much.
Okay.
Bye bye.
Bye. Bye.